I'm going to, one step at a time, graph a quadratic function that is in vertex form. If you watched the other video first, that was in standard form. This one is in vertex form. So some things are easier to find in vertex form, some things are easier to find in standard. This is your vertex form. You can probably guess by the name what's going to be easy to find in vertex form. H and K have to do with your vertex. If you know your transformations of functions, hopefully you remember what makes them move left and right and up and down. That H value indicates a shift left or right. That K value indicates a shift up or down. Now, before we even get into that part, what we're going to decide is whether this is going to be facing up or down. Because my A value is negative, that number in front of the parentheses, this is going to be facing down. So because this is facing down, we would consider the vertex a maximum. It's the highest point on our parabola. Next, we're going to find the vertex. I told you that H and K have to do with the vertex. If you know your transformations, you're just going to use those. A -1 in the parentheses is a shift to the right 1. A +2 on the outside moves up 2. So a point that moved right 1 and up 2 would be the point 1, 2. And that's all you have to do for your vertex. Next is your axis of symmetry. Your axis of symmetry is just the x value of your vertex. So we already have our vertex. It's 1, 2. So our axis of symmetry is just x equals 1. Please make sure you're writing x equals with your axis of symmetry. If you just write the number 1, you're not giving enough information. Next is the x-intercepts. Now, you're probably used to using the quadratic formula or factoring when you find x-intercepts. However, I don't have standard form in front of me, so I can't factor and I can't use the quadratic formula. You would have to convert to standard form first before you do that, and that's going to be a lot of work. So don't do that. I'm going to show you how you can find the x-intercepts here by just setting y to 0 and solving for x. So now that y is 0, I want to move everything away from the parentheses. I'm going to start that by subtracting 2. Now, the negative also needs to move. Right now, it's negative times or -1 times the parentheses. I'm going to get rid of that by dividing by -1, or you can multiply by -1 since you get the same result. So I'm dividing both sides by -1, which gives me +2 is equal to x minus 1 squared. In order to solve for x, I need to get rid of the exponent. So to do that, I'm going to take the square root of both sides. And when you take the square root of both sides, you must include plus or minus. Taking the square root of something with an exponent of 2 cancels out the exponent, so all we're left with is whatever was inside, which is x minus 1. The last step to get x by itself would be to add 1. So we have x equals 1 plus or minus the square root of 2. Now, normally I would say to leave it like this because the question doesn't say anything about rounding. However, because you are graphing, I don't know about you, but I don't know what 1 plus the square root of 2 looks like off the top of my head. So you can put square root of 2 in your calculator and simplify that way so that you know where to put the points on your graph. Square root of 2 is approximately 1.41 with a bunch of decimal points after that, or decimal places after that. So we end up doing 1 plus 1.41 and 1 minus 1.41. Which gives us the x-intercepts of positive 2.41 and negative 0.41. And those are rounded. Those are approximate. The last thing I'm going to find is the y-intercept. When you have standard form, the y-intercept is just your c value. But we don't have standard form, so you actually have to do some calculations in order to find your y-intercept. I'm going to do that by setting x to 0 and simplifying to find y. You must start in the parentheses according to the order of operations, and then after that you can square the number. Negative 1 squared is positive 1, but we still have a negative in front. So you should get positive 1 as your y-intercept. Now I've got everything I need. I'm going to go ahead and put it on the graph. So the first thing we found was our vertex, which was 1, 2. The axis of symmetry goes through the vertex. We also have our x-intercepts at approximately 2.41 and negative 0.41. This part doesn't have to be perfect. And finally, our y-intercept is at positive 1. Kind of ugly, but that is your parabola. Remember, we decided in the beginning that it should be facing down, and this one is.